Just before starting simulation, I will just describe about PV and MPPT algorithm. Okay, then we have to learn just what's PV array. PV array basically that's built by using semiconductor devices known as solar cells, PV cells. Uh, that means when light falls on surface of PV cell, it will generate some electricity. That's already we have learned. But we have to learn some more thing about it. The power depends on irradiance and temperature. That means there is a relation between power and irradiance and power and temperature. That means when irradiance increase, power will be increased, and when there is a temperature increase, power will be decreased. That we have to learn. Okay. So when we simulate, we have to consider about irradiance and temperature. Okay. Then amount of solar energy that strikes given area. That means normal energy available in square meter, that will be 1 kilowatt. So energy should be solar irradiance should be mentioned in watts per meter square. Irradiance, that's in insulation, that means light available, that can be called as irradiance. Okay, this is a picture of PV array. We'll just discuss about what is PV cell. PV cell is the semiconductor device that will generate a DC voltage according to the light. Then PV panel is combination of PV cells. That means in a PV panel, there will be a combination of series and parallel cells. And PV array means there will be a number of PV panels. Finally, for an application, there will be PV panels using. So PV panels may be arranged in series or parallel combination of PV. PV array will be the series and parallel combination of PV panels, and PV panels will be series and parallel combination of PV cells. Okay. This is the PV characteristics. When we go for an electric device or electronic device, we will first learn about characteristics. That means what will be the behavior between voltage and current. This is something similar to DC source. Here we can see that there is VOC and ISC. The curve is connected in the blue curve is connected between VOC and ISC. We can see that there is no load. That means in y-axis current is 0. The voltage will be maximum. That is known as VOC. Without load, there will be a voltage. Then that voltage will decrease with increase in load. That means it will decrease step by step, linearly up to certain level of voltage, and after some time it will decrease very fast, exponentially. We can just like it is almost similar to IV Cara of diode, because it is PN junction device, but forward voltage will be higher than normal diode. And there is a green curve that is known as power curve. We can see that when the terminal voltage or current varies, power will be varying. That means it will be looking like a hill. So there is a top. That top point is called as maximum power point. That means when we consider, that is simple thing, I will simplify the thing. When we consider a PV with a 2 terminal, that means PV is an energy source. When we apply a load should be matched with PV parameter. Parameter means every time PV parameter will be varying, just like irradiance, temperature, and both parameter will be varying. That means with every variation of irradiance and temperature, load should be varied. I will show another picture. That means in different irradiance. Here we are having a different irradiance curve. That means for every irredence level, there is different peak points. That means we have to vary the load. That means power is different. We can see that power is different. Because power is different, we can see that a load should be varied according to the power. That means every irredence change, load should be automatically adjusted. That means when we apply a PV and a rheostat, suppose we have a PV and a rheostat. In that case, the rheostat should be varied in every change in irredence and temperature. That is the thing of MPPT tracking. Then I will show another picture. It's a temperature difference. Suppose irredence is same. Then temperature is varying. Volt per cell will be varying, and according to the variation, we should vary the load. That means when there is a variation in temperature and irredence, temperature or irredence, we should vary the load. I think you all got basics of method of MPPT. That means variation of load. That is simple. MPPT is simple. Vary the load to get maximum power. Just like normally, just like exactly similar to maximum power transfer theorem. That means when load is equal to internal resistance, power transfer will be maximum. Exactly similar. Load should be varied according to irredence and temperature. Here we'll talk about MPPT more. Then practical variation of load is not possible because load will not be a rheostat or variable something. So we will discuss more about MPPT tracking. MPPT tracking is, as we discussed, that's the tracking of maximum power point. That means tracking of voltage and current to get maximum power. That means we have to vary the impedance of load. Here I will discuss about more about its block diagram. There will be an electronic circuit just like a converter. So we can vary the duty ratio of converter to achieve sufficient impedance. MPPT, normally MPPT variation is done. Normal case I am discussing. In normal case, MPPT is varied by varying duty cycle of converter. By increasing and decreasing, we can track MPPT, which is the maximum power point operating point. We can fix to that point. We'll discuss more about MPPT tracking methods. After that, we'll simulate it. There is different types of MPPT techniques. That is two methods are basically that can classify into two. That is direct and indirect MPPT. That's nothing. Direct MPPT means the operational condition will vary directly. That means if it is a duty cycle, we will vary the duty cycle of converter. One method we can call as P and O, and INC, incremental conductance. There is one more thing is fuzzy logic. And indirect method that can be called as a FOCV, that is open circuit voltage method, and other neural network method, and temperature based tracking and fixed voltage technique. Here we are going to simulate about P and O. P and O means perturb and observe. Perturb means apply some disturbance and observe the change. That means just like tuning a radio, we will just rotate the knob towards left and right. Then we will find the actual desired channel. Similar way, here we will apply some step-by-step perturbance. That means increase and decreasing operating point. And we'll check whether it is highest point or increasing or decreasing, just like a volume increasing or decreasing. It is known as a hill climbing method because it will climb step by step, just like climbing in hill. These methods, just like P and O, incremental conductance methods, are known as hill climbing method. That method is comparatively simpler but slower than other fastest method, other intelligent methods. Perturbance, actually perturbance can be done either in duty cycle or in operating voltage. That depends on the operating methods. Different duty ratio, different delta change in duty cycle will be applied. Then we will check. That's a simpler method. We'll apply some change in duty cycle and we'll wait for some time. After that, we'll check what is happening. If it is increasing power, then we'll continue increasing. Otherwise, if it is decreasing power, we will continue decreasing a duty cycle. This is the algorithm. Just a brief algorithm: measure voltage and current. Then we will compute power. By computing power, we will compute delta P. The delta P means change in power. And
Aslam, can you just use the pointer to point the relevant block you are talking about?
I will check it up.
Yeah.
Is it visible, my pointer?
Oh, yeah, now it's okay.
Okay, thank you. Here there is compute. We'll compute dV based on current and previous voltage. That means simple. We'll measure the difference in. Sometimes the pointer is disappearing. So sorry. That means we will measure current and previous voltage, and we'll calculate the delta V. That means difference in voltage. And we'll compute delta P. That means current power at this time and power after some time. That means delta P. After calculating delta P, we will decide four things, four track. That means if delta P is less than 0, that is power is decreasing. Power is decreasing, there will be two chances. Power is decreasing with increase in voltage, and power is decreasing with a decrease in voltage. We will check power is increasing or decreasing. If power is decreasing,
yeah, I think we need that PV care also for understanding that. Otherwise, I don't know how many students may understand, because when power is decreasing, there are two options, right? I think if you can include that PV care also in the same slide, then yeah, then it will be more useful.
Okay, we will see it this Chiara. That means we will change duty ratio. Duty ratio means when duty ratio increased, PV voltage will be decreasing. That means when we can control PV voltage by changing duty ratio. By changing duty ratio, terminal voltage will be varied. Here the 0 to VOC will be marked. When voltage is decreased, there is a curve, a blue curve, that is the IV Chiara. In this IV Chiara, when voltage is decreasing, then if voltage is decreasing and power is decreasing, we will change in reverse mode. That means, that is simple. We will try four conditions. That means if power is increasing with increase in voltage, we will try to increase the voltage. If power is increasing with a decrease in voltage, we will try to decrease the voltage. That we will try in direct characteristics. Actually, we will simulate one PV. If power is decreasing with increasing voltage, we will go reverse. We will decrease the voltage. If power is decreasing with increasing voltage, we will decrease the voltage. That is a fact. That is a simple thing. I will discuss it again. That means there is delta P and delta V. Only two things is to be considered. That means if power is increasing with increase in voltage, we will continue increasing voltage. If power is increasing with decreasing voltage, we will continue decrease voltage. Based on that, we will have four conditions: decrease duty cycle, increase duty cycle, and other side there is again decrease and increasing voltage. That we will simulate using an APV, and we will vary the load. Based on that, we will track MPPT manually. I think it should be understood by varying real PV model that we will use. This is a basic thing. This only things to be noted, that we will measure voltage, current, and calculate delta V, change in voltage and change in power. Based on that, we will decide whether it is duty cycles is to be increased or decreased based on power and voltage. There is two parameters. Based on power variation, we will check that is based on increasing voltage or decreasing voltage, or power reduction is based on increasing and decreasing voltage. Similar way, we will compute duty cycle, and based on that duty cycle, we'll operate the converter. We'll check in real simulation itself. Okay. If anyone have doubt based on this, I will clear before going to next section. Please ask if anyone having confusion. Yes.
So if anybody have this some clarification around this P&O algorithm, you can unmute and ask right now, because we are going to simulation. So the concept should be clear before going to simulation. Hope it is clear to all.
Okay. This is a circuit for applying MPPT. The simple circuit, yesterday we have done a boost converter. Similar way, here instead of DC source, we are having a solar PV. We can vary the duty cycle to control the power flow from the PV side to load. That means duty cycle can be adjusted to vary the power flow. That means we are not adjusting load.
How to download this, sir?
That when you click there is a at the right side there is a download option is there.
Yes, sir. While doing that is redirecting to your mail ID something.
No,
MATLAB
no.
I think it will ask for some account, MATLAB account. I think.
Maybe yeah.
If it is like that, we will share Google Drive link. And
okay, so actually they are asking for that MATLAB ID.
Because you may not have logged in. That is why.
Okay.
MathWorks you should have already logged in.
Okay.
Excuse me, sir.
Please. Yes.
So I have downloaded the file, but when I'm trying to run it in MATLAB, the file is not opening, sir.
Which is the MATLAB version you have?
R20, sir. R20.
MATLAB release 20. That means year 20.
Yes, sir.
That is, I have converted it to MATLAB 16 itself. It should open. Any other having trouble in open file?
So can you once tell me how to open the file? Is it we should just go to the MATLAB and then just open the file there, right?
Yes, sir. So from here, the window is available. Is visible to you?
Yes, sir.
Yes. From this window, you can open. You have to go to this location, at this location. Then you can open. Just right click it, then open. Otherwise, you can double click. Just double click, it will open.
Yeah. Okay, sir.
Okay. I'll discuss about brief about this. Then by that time, just try to download that file. In this simulation, we are having a PV model. That means a math block which will behave as PV model. Here we are having different settings. We can change that is PV array. We can set number of parallel strings and number of series strings. That means different number of panels can be connected in series and parallel. That means here we have to apply 1 and 1 only. I have already selected, and open circuit voltage of PV is selected, and VMPP, everything is selected. I have selected available, commercially available PV model with 250 watt. Everything is set, that is available in MATLAB itself. MATLAB 2015 version, actually, I will try to share that file also. 15 basically for lower version PV simulation is not better. I think from 15 and below PV model is not there. Ansel, please download file. Are you able to download that file?
Yes, sir, I could download that file, but it couldn't open in 2015 version.
15
Actually, in
it won't
2015
work.
version, there is MPPT model also, sir.
PV model.
Yes, sir. Yes, sir. I have worked in it. That's right.
So just try to listen. We will convert that file and we'll send to you.
Okay, sir. It would be helpful if it's so.
Okay. I'll start the simulation. There will be some version issues in MATLAB. For lower version, it will be tough to convert that file. Is it visible my screen with a PV and the converter and everything? Is it visible? Please respond to me.
Yes, sir. It's visible.
Okay. Here we are having PV module and a capacitor and a boost converter in this block. In this boost converter, we can apply duty cycle from external block, and the load is connected. And here an MPPT system, that is MP&O algorithm, is connected. We have applied VPV and IPV into the MPPT algorithm block. Before going to the simulation, we will work on it. If anyone having a problem in downloading this one, you just try to add a PV model only, just like this, a PV model and irradiance temperature. I'm just commenting these portions. We can take a block named PV array. Then we can set number of parallel strings and number of series strings to 1. Then we can select this one, LUMOS, LS250 or similar thing that is having a power of 250 watt, and VOC is 37 and VMPP is 30 volt.
Google Drive.
It is shared in Google Drive. Please share the link to the here we have shared a link. If anyone having problem with downloading in MATLAB Central, you just try to download from Google Drive. Ansel, please convert the file into MATLAB 15 and share it again also.
Okay.
That one also, 2015 version. If someone having 2015, they can download the next link. Ansel will share in chat box. Okay. Then here I will try to give an example to learn about PV. Just try this. Just connect.
Sir, one more thing, sir. Can you open the PV array, sir?
Yes, I will open, please.
In that, like you say, parallel string is 1 and series parallel string is 1. What does it mean?
Both are one. Your voice is not clear. I couldn't hear you.
Can you hear me?
Yes.
What does, if you say like parallel string is 1, series connected module per string is 1. If you keep like 4 and 4, 3 and 3,
actually we are going to simulate only one PV panel. We are not using entire array. Just because of converter is designed for that one. We can use parallel strings and series strings based on our total power requirement. Now we are studying just a panel only. By just learning a panel, we can connect panel in series and parallel to make PV array. Okay. Now it
so like if 2 by 2, then the power is going to be increased, right?
If it is 2 by 2, total there will be 4 panels. Then 250 into 4, 1 kilowatt will be available. 1 kilowatt with the 2 in parallel and 2 in series. That means we will get open circuit voltage of 37 into 2 and power of 1 kilowatt.
Yeah, that makes sense.
Okay.
Thank you.
Okay.
And what about the module like lithium, different kinds?
Actually, here normally we are using available modules. It's the manufacturer name we have available. We are not discussing about PV material type.
Okay.
Okay.
Thank you.
Okay. Then currently we are having a PV and a load. Then just we'll try to evaluate PV module. Then we are having 250 watt 37 volt VOC and 30 volt VMPP. Then its maximum power point current is 8.31 amperes, and 8.31 into 30 is the power that we can calculate load. Based on this one, we can calculate maximum power resistance at maximum irradiance 30 divided by 8.3. That means 30.1 divided by 8.3 will be 30.1 divided by 8.3, right? 3.6 ohm. We can apply resistance as 3.6 ohm, just giving the resistance to get maximum power. Okay. Then there is a measurement port. We can apply a demultiplexer or bus selector here. Then we can connect a scope. Otherwise, I will add a display. Display of voltage and current. Okay. I'm just simulating to get voltage and current value, and we'll calculate power also. We can product voltage and current to get the power. Here I'm just multiplying voltage and current to get power value, and power is also displayed. Okay. Then I am just running this one. Then we are getting voltage and current. That's voltage is 30.1 and current is 8.3. Power is 250 watt. This is the calculated value. Just we have calculated a load value based on maximum power point. Then I'm just trying to reduce irradiance by half. That means I'm just applying 500 irradiance. That means 500 watt per meter square. Then the power should be half. I'm just running, but we are getting power of 69 only. In this case, I'll get the MPPT curve. From this one, we can see the curve with a different irradiance. I'm having 1500 irradiance. Then I'm just plotting. We can see the curve. Is it visible, this curve?
Yes.
Yes. We can see that for 500 irradiance, the power is 250, and for 1000 irradiance, power is 250, and 500 irradiance, power is half, close to 125 watt. That should be the power available at this condition. That means we can check again. First, I have applied a resistor that is correspond to 500 irradiance. That means at 1000 irradiance. At 1000 irradiance, at a resistance of 3.62 ohm, we got a power of 250 watt. Then I have changed irradiance to 500. In this condition, we should get power of 125 watt. In this case, power will be half. That means resistance should be adjusted. I'm just adjusting resistance to see the variation. I am just changing the resistance to 5 ohm. Just changing the value. This is the way of tracking MPPT. Then we can see that I have increased the resistance, power is getting increased. And again, I am increasing the resistance to 6 ohm. Now power is 114. I am again increasing the resistance to 7 ohm. Then power is 126. Then I am changing resistance, increasing resistance again to 8. Now power is 126. Now power is 124. I am again, power is decreased. I am again increasing resistance to 9 ohm. Power is 117. That means at 7 ohm or approximately 7 ohm, we are getting maximum power. That means we have to adjust the load to get maximum power at every variation of irradiance. That means irradiance means sunlight. Every time when irradiance varying, load should be varied. That is the fact of MPPT. That means load adjustment based on irradiance. That is MPPT. Here we have done an MPPT. That means we have just adjusted resistance by increasing and decreasing by certain value, 1 ohm or 2 ohm or something. That is the delta change I have applied. Based on that change, we can track maximum power, independent of knowing irradiance. Suppose irradiance is here, I have applied 400. At that time, power is 85. I just changed this value to 8 ohm. 85. That's 96. We can see that power is increased. Then we'll increase the resistance again. Now it is 96. 101. Then again I'm increasing to 10 ohm. Power is decreased. That means at 9 ohm I have got approximate, that is approximate value, because I have adjusted very wider value of 1 ohm to get the maximum power. That means by varying the resistance, we will get maximum power. That means by varying the load, we will get maximum power. This is I'm trying to understand you. I hope all of you got an idea of MPPT. Please give me some response based on this. That means MPPT tracking is purely load variation to get maximum power. Please respond someone to, if anyone have any doubt, please respond to me.
For electrical engineers, this is basically your maximum power transfer theorem. Basically, electrical engineers are studying that. And load resistance is equal to internal resistance of the network. Maximum power is transferred. We are just applying that here.
Okay, if some of you got clear, please give me some response in chat box. I'll continue. Otherwise, please unmute your mic and give me your response.
And I think electronic engineers and communication engineers are also using this concept for impedance matching. Basically.
Yes.
Yeah.
Okay, load resistance matching. But in normal power transfer theorem or impedance matching, there is here some difference, because this is a non-linear load. That means source resistance, that is exactly similar to power transfer theorem, but in this case, because of non-linearity of PV, that is semiconductor device, that is complex behavior than the maximum power transfer theorem. Okay, then I am just commenting out this session and enable.
Hello.
Yes, tell me.
Sir, based on the output power, we need to change the MPPT tracking. Am I right, sir?
Yes, yes,
Like that, we need to configure the system. Like for the any algorithm, we need to configure like that. Based on the output, we need to change the input.
based on the power available, we have to adjust the operating point,
Okay.
just like load variation. Okay.
Okay.
Okay. In practical case, I am just going to our simulation. In practical case, load variation is not possible because load may be a fixed thing and load
One
may be.
second, I think for clarifying the previous question, I think that the PV carrier, if you have that PV carrier for different radians, then I think that will clearly, that already you have shown it, then I think that doubt will be easily clarified, I think. So we will change accordingly for the P variation. Yeah, here, yeah, for different, we can see the voltage, the DC to DC converter will change the voltage, right, Aslam? Right.
DC-DC converter will change the impedance between.
Yes, by adjusting the duty ratio.
Duty cycle.
Okay, okay, sir.
Okay. Here we are having a load, fixed load. We cannot vary the load. Just take a lamp or something and just consider about the battery. Most common thing is PV converter and battery. We have to charge. We have to convert the power from PV to battery. We have to charge the battery. At that time, we cannot vary the load. At that time, load should be fixed. Here, I have applied a load of 50 ohm. That cannot be varied practically. In that case, we will apply a converter here. That means a converter will convert primary voltage to secondary voltage to different ratio based on the duty cycle. Voltage conversion will lead to current conversion. That means current will be decreased if voltage is increasing. Just like in transformer, power will be ideally power will be same. That means impedance will be varied. Impedance can be adjusted by varying the duty cycle. Here we are having a PWM generator. Yesterday we are having a boost converter simulation. The same boost converter simulation used here. Then a duty cycle from external module is connected to control MPPT. Here from PV we have taken voltage and current, and it will calculate the duty cycle. That means every time we can adjust the duty cycle. I just disconnecting duty cycle, then we'll change manually. Here I'm just giving a duty cycle of 0.5. Then just we'll run. I'll just add a power measurement here. Meanwhile, you can open this file, and if it is possible, you can run along with me. I'm just adding voltage and current measurement and power. Okay. Then I'm just increasing simulation time to 0.5, running the simulation. So we are getting a power of 130 watt approx by giving a duty cycle of 0.5. I'm just changing the duty cycle to 0.6. Then we can see the variation of power. Now power is went to 170 watt. Is it visible? 170 watt near. Okay. Then I'm just changing duty cycle again to 0.7. Then now power is close to 230 watt. Then changing again to 0.8. You can see that power is decreased when 0.8 is applied. Then I am just decreasing the value 0.75. Based on certain value of increase and decrease, we can find out maximum power. That means when there is a variation in irradiance and temperature, we can change the duty cycle. So in our condition, it should be changed automatically. I'll discuss more about it. And just connecting MPP algorithm. We will see the variation of duty cycle. After that, we will discuss algorithm. You can see the variation of duty cycle. You can see the duty cycle will get automatically increasing step by step. After reaching a point, it will oscillate. It will perturb in some values. It is reached maximum power. Is it visible in my screen?
Yes, yes.
Okay.
Yes.
Then after reaching a maximum point, it will try to decrease to certain value, and again it will increase. Then in that point, it will oscillate. After a certain point, it will get decrease. Based on delta duty cycle, delta D and delta V, we can control the accuracy. This is the method we are using, fixed duty cycle variation. For getting more accuracy, we can change the duty cycle dynamically. That means in high power variation, we can vary the duty cycle in high range. When there is low power variation, we can change the duty cycle in low range. That means we will get more accurate result. We can see that we are getting a power that's close to 250 watt. I'm just changing irradiance from 1000 to 500. Then we can see that simulation got end. I will simulate again. From starting point, it was decreasing to get maximum power point value. That means for every irradiance, it will calculate, it will try by changing duty cycle, by increasing and decreasing duty cycle, it will track the power. By tracking that power, it will oscillate on certain value of duty cycle for getting maximum power. We can see that every irradiance, it will change automatically. Now we'll see more about the algorithm we have used. Here we are having a MATLAB function. Before the function, we have applied a rate transition block to reduce the speed. That means MPPT algorithm should work slowly. That means when a perturbance applied, we have to wait for some time. Here I'm just giving the wait time of 10 milliseconds. That means we will apply a duty cycle and we'll wait for 10 milliseconds. After 10 milliseconds, we will check again. Then again we will apply another duty cycle and we will wait for another 10 milliseconds. After 10 milliseconds, we will check check the parameter again, it will continue. Here we are having a P&L algorithm. In this one, I have applied the same algorithm that we have seen in flowchart. Just calculated voltage and current, and based on that we have calculated power, and current voltage now minus voltage previous, that will be delta V. Power now minus power previous, that will be delta P. Based on that, we'll check if delta P is negative, that means power is decreasing due to decrease. If you again check if it is due to decrease in voltage, then we'll decrease the duty cycle. That means voltage is to be increased. If voltage to be increased, we have to decrease the duty cycle. That's inverse relation. And another case, if voltage is increased, we will increase the duty cycle. In similar way, if delta P is positive, that is power is increased, that is due to, if it is due to delta V negative, that means decrease in voltage, we will increase the duty cycle. If it is reverse, we will change the reverse operation. That means only two conditions: increased duty cycle or decreased duty cycle based on increase or decrease in power and voltage. We'll check power is increased. If it is due to increase in voltage, we will increase the voltage. If it is decrease in voltage, we will decrease in voltage. Just 4 combination are there. We can apply this condition like this. You can study if you are having same simulation in your hand, and based on this we will get a duty cycle. That duty cycle parameter will be in lower speed, that has to be converted into higher simulation speed. Now it is converted to higher simulation speed, then we have applied to the converter circuit. Based on this, it will just run by giving a duty cycle in start, and it will check voltage and current from here. Then it will compute change in power and voltage, and it will again give duty cycle. Then it will reach the maximum power point. This is a basic thing in MPPT we have done. This is the simplest method. There are lot of techniques. Here we have used perturb and observe method. There are lot of things available for calculating MPPT, just like incremental conductance and fuzzy logic methods, and there are few other advanced methods just like particle sum optimization, and there are fastest and faster methods are there based on our application. If our application is lower power, we'll go for lower quality algorithm. If we are having higher power application, we will use high power high quality computing algorithm. That means if power variation is significant, we'll put more effort in MPPT algorithm. In my application, I have used the P&O in a water pumping application. Similar way, but in that application there was no converter. Instead of converter, I had an inverter with pump. I have applied a variation in pump speed to achieve maximum frequency. That means here we have changed duty cycle to get maximum power. In my application, I have changed the frequency of pump to change the motor speed to get maximum power. That means whatever the parameter which can vary the load power, that can be used to change, that can be used to find the MPPT point. That means load variation should come into the picture. This is the fact I am just discussed about the MPPT for this time. And based on this example, you just try to run. If it's not possible now, you just try to run from your side, and based on this you can study MPPT methods. And here we are having algorithm, and you can improve. You can also apply other methods in this one. and if it is required for your future application, you can implement. And one more thing, for hardware implementation purpose, we will make similar circuit in hardware. We will apply a PV, and we build a converter and load, and we can apply this algorithm into a microcontroller. That means a microcontroller will generate pulse width signals, PWM signals, based on maximum power point tracking. That is, MPPT algorithm should be in the microcontroller. That's a control algorithm, microcontroller based algorithm we can use. I'm just trying to wind up. That means because of lack of time, I have just filed. I'm just trying to wind up after some discussion. Please let me know if you have any doubt that can clear in a short time.
For this, an Arduino will be enough, right?
For this one, Arduino will be enough, because a low speed algorithm is used for P and O. In this case, an Arduino is enough.
Then one more, how can I implement a closed loop control for this?
In this case, there's no need of closed loop control. There's another method that's known as indirect MPPT. In that case, we'll apply a closed loop control to control input voltage. In that case, we can apply similar closed loop control that we have applied yesterday, but feedback will be from the PV side. In that case, we will not vary the duty cycle directly. We will vary the voltage command. Yesterday we have given 24, 22 such commands for voltage. That command will be varied by the MPPT controller. That means MPPT controller will generate voltage instead of duty cycle.
Okay, for that indirect control, so for controlling the input voltage, you need one more converter.
No. We have to apply a closed loop system only.
We need a modified algorithm, or
algorithm can be modified by changing duty cycle to voltage. We can update relation here. For increasing voltage, there is decreasing duty cycle. This sign should be varied, and duty cycle, because of duty cycle, its range is 0 to 1. But in case of voltage, we have to identify the range of voltage in PV. Then that we can apply upper and lower limits.
Then we will convert that into a PWM, corresponding PWM voltage.
That voltage will be applied as command for the control loop. The control loop will generate the duty cycle.
Which control loop we need an extra control loop?
Same PID control loop that we have used.
That PA control loop, closed loop control.
That's indirect control method.
In
my application, water pump application, I have used indirect duty cycle control method. That means I am just creating a voltage command from MPPT block. Based on that voltage, I have a control loop. That control loop will adjust the motor speed to maintain the bus voltage. That means MPPT controller will generate a voltage command only. Another control loop will maintain that voltage using control system. That means MPPT is not direct varying any frequency or duty cycle. It's just generating the voltage to be achieved.
Okay, say assume my application is a constant voltage application. Okay, my load need a constant voltage. In that case, what can
in that case, it is not possible. Actually, in this application, if we need a constant voltage at output load, it is never possible, because here we are having a resistive load. That means voltage across the load will be dependent on the power. In this case, power will be varying. We will never get a constant voltage on output side. If we need a constant voltage on output side, we should use a support of battery.
Sir, is it possible to get the constant voltage and MPPT at the same time with the converter, whatever you are showing right now?
Constant voltage on output side.
Yes,
constant voltage as well as the MPPT algorithm.
No, that they never meet, because
but Aslam, say I want to connect this to grid. then you have to maintain the voltage. Yeah.
Yes, yes. In that case, if we, suppose in grid case, I will give an example value. Just grid voltage is 230 volt. At that case, voltage across the bus. Here I am just marking bus. Is it visible to you? Here
Yes, yes.
we have bus. In this bus, we should keep 400 voltage. Okay, clear. In that case, that 400 voltage is maintained by inverter, not by the MPPT controller. That voltage is maintained by inverter by applying current to the grid. That means from left to right control is coming, not like a control ordinary control system. Load will adjust itself to get constant bus voltage.
Then in that case, how we will achieve the MPPT?
In that case, load will adjust bus voltage automatically by varying the current injection. At that case, MPPT will work in normal. It will vary the duty cycle according to the power available. It will generate a duty cycle and it will transfer maximum power to the load. And then at that case,
in that case we don't have the DC converter in the
actually your voice is not clear. It is getting cut.
Trying to so your case, so is no DC converter in the PV and inverter.
Sorry, I couldn't hear you.
I think Islam, I think his doubt is that so we are using an inverter at the output side to control the voltage. Okay, again there is a change in voltage happening. So his question may be then in that case, how are we able to track the MPPT?
In that case also, actually, in that case, here we are having a resistive load, but in that case, in case of grid, actually that is dynamic load. The inverter is not constant load. It will adjust automatically based on the power. It will adjust automatically to get the constant bus voltage, not load voltage, constant bus voltage. To get constant bus voltage, inverter will adjust its current automatically. There will be another control loop to maintain the bus voltage. So based on bus voltage, when power increase, bus voltage will try to increase. At that time, inverter will increase current injection to the grid, then voltage will be decreased to the reference value. Then if power is decreased, terminal voltage, that means bus voltage will decrease. At that time, again the inverter will work to maintain that voltage. That means automatically vary the current injection to the grid. At that time, MPPT work in normal case. That means that is because of load is dynamic. We can maintain constant bus voltage irrespective of power available.
Surrender. Good evening, sir. And partial shading conditions, we have experienced multiple power points and tracking the multiple power points. Suppose constant irradiation changes will be coming, then DC voltage will not be constant.
Okay.
And if you are connecting a water pump or a motor in the output of DC to that converter, there will be disturbances in that motor or that converter. In that case, what we have to control, the BLDC motor we have to control, or that output DC to DC converter.
Okay. For getting a certain range of output voltage in case of partial shading, that's a complex thing. In partial shading condition, we cannot lift the voltage to higher level. At that time, the main suggestion is to avoid partial shading, limit number of series cells. Use that panels in parallel to overcome the partial shading issue. Then you have to, at that time, you may have to add a converter. That's another challenge. That means in series cells can be parallel to avoid partial shading. And if partial shading occurs, there will be multiple peaks. At that time, we cannot go for P&O algorithm. We should go for PSO and colony and similar algorithm to meet the partial shading condition.
Okay,
Hello.
sir. Then be it.
Yes.
Thank you, sir.
Okay.
Thank you. Thank you.
Hello.
Thank you for the question. Yes.
Sir, sometimes in grid, like harmonics will be there. Like in nowadays, PV systems are connecting to grid, like up to low voltage also, up to 10 kilowatt or 5 kilowatt. They are connecting to the grid system. That time maybe some inter-harmonics or harmonics happening. Due to that, the flickering and maybe it might be go to the disconnection of the grid, all those things. It might be happen because of the induction motors or non-linear loads. That time how it will be tracking, sir, like this MPPT, and what we have to take like in this MPPT algorithm, and that condition.
Actually, okay. In that case, there will be, for grid connected inverters, there will be at least two things. One will be DC to DC converter, and second will be the inverter side. In inverter, there will be current control algorithm to maintain the current. If there is a disturbance, if there is an intelligent control algorithm for controlling the current, it will maintain pure sinusoidal current to the grid, independent of surges and harmonics inside the grid. We should have a proper algorithm, just like when we use just like hysteresis current control algorithm. It will maintain current irrespective of fluctuation in the grid. That's based on the control algorithm, not depend on the MPPT side. It should be, it is purely dependent on the inverter and control part.
Yes, sir. But as per my knowledge, like I have read some of the like journals and all. In the in MPPT, two things are there: sampling rate and perturbation step size. These two things changing the drastically MPPT performance. So this some of the journals, they said that from this we can adjust the MPPT algorithm, and accordingly you can change the duty cycle ratios.
Actually, there is a lot of experience and researchers going on in MPPT algorithm to reduce the settling time in certain variations, and to reduce the oscillation in MPPT P&O. P&O is the least complex algorithm. It's a very simplest algorithm, but in a higher application, it will need a more complex algorithm, just like INC, or there are a lot of mixed algorithm, including fuzzy and P&O, to reduce the oscillation. There are a lot of research going on to solve these problems in the grid.
Okay, sir. If any doubts on that, I'm working some on that. So can I contact you, sir?
I'll try to cooperate, but this is not a simple thing. It is a research topic. So a lot of scientists are taking research in this subject.
I'm only just trying to. If anything is doubt, can
I'll try. Okay.
So you can write to him, Aslam. Can you once again type your mail ID in the chat box so that
I'll give my mail ID here.
Yes, sir.
Otherwise, if it is missing, you can search our contact using name inQbe.
Okay, sure, sir. Thank you.
Okay. Yeah. Okay. If anyone have,
is the form is still not opening? Because it's opening for me.
Yeah, it's opening for me also. Me also, it was opening. What is the problem? Maybe for one or two that, because for me also that form opened actually. So all the participants, please fill up the form for getting the certificate. This is mandatory. Feedback form mandatory for getting the certificate, and getting updates about our future programs. So please fill up the feedback form. It's very important. Your feedback is the most valuable thing for us. Okay, so do fill up that.
Okay. Meanwhile, if anyone have a doubt, I will clear within the time limitation.
Yes.
So
yeah.
We will get the video presentations all to the participants.
Presentations. What are you asking about?
The recording video.
Yeah, surely we have a YouTube channel. And once again, although can you please once again type our YouTube channel link? We will upload all the recordings in 2 weeks in our YouTube channel. So please subscribe and get the notification. Okay, enable that so that you will automatically get updated, notified about our uploadings. Okay, so please. So that is where we advise. Yeah.
I have posted the YouTube